Today we got back from spring break. It's back in the group. Okay, we're going to do the back in the group problem. I began today's lesson with trying to get you to see that it's important that you know in the Pythagorean theorem, there's only one side that's going to be in the same place every time. Which side is it that will always be in the same place? That's right. The hypotenuse will always, because it's not moving, it's always across from the right angle. The legs can move around, but the hypotenuse can't move around. Now, the biggest mistake that I see young mathematicians make is they don't start out every single problem exactly the same. Guys, these you can start out 100% the same every time. Start out with a squared plus b squared equals c squared. Literally write a squared plus b squared equals c squared. One of your legs is x, one of your legs is 10. So either write x squared plus 10 squared or 10 squared plus x squared. Start them out the same exact way every time. X squared plus 10 squared equals 11 squared. Guys, it's not going to change where the hypotenuse is. 7 squared plus x squared. No, that's not right because that's a leg. So 7 squared plus 13 squared equals x squared. Guys, look at the difference here. That's what it is that you're trying to learn. That when the hypotenuse is over there by its, that's the variable that we're looking for. You do it one way. But when a leg is x squared, then you got to do it a little bit different. These problems are not done the same exact way. It's not one problem or one way to do them all the time. It's sometimes you do them one way, sometimes you do them another, based solely on, that's right, whether or not you're finding the hypotenuse. That's what I meant. That's what I meant right here. A lot of you took the problem and you stopped and said c squared equals, on the test, c squared equals 87. And then you stop. Don't stop right there. Go c squared equals 87. So c is the square root of 87. Now, whether or not x squared equals 21, x equals square root of 21, whether or not that simplifies, we still got to practice. We're not quite proficient at that yet. We still don't understand the rules for simplifying radicals. Remember, it's circle one, cross one out. Circle one, cross one out. Circle one. If you can't circle one, you can't cross one out. You can only circle and cross them out when they're pairs. 144, now the hypotenuse is over there. 144 plus 64 equals x squared. 208 equals x squared. Again, guys, don't stop right there. That was the biggest mistake we made. We stopped at 208 equals x squared. The second biggest mistake that we made is you guys went running for those calculators. Guys, that calculator is not the key to this. Being able to punch buttons on your calculator is not the key. As that's not what a mathematician wants to do. Andrew, I believe, sorry for saying Andrew there. Andrew was the nickname of the person that I want to pay attention right now. Not really the person I want to pay attention. Okay? You hear me? I have to filter that out somehow. But anyway, we want to make sure we're not running to the calculator to put the square root of 20. Guys, leave square root of 21. That's a good answer. Nothing wrong with that. Mathematician, write square root of 21. I hand it to the engineer. The engineer gives us more exact answer than that, but he changes it. The carpenter can use 3.14 because if he's got a gap, he just puts caulk in that gap. So the carpenter doesn't need exactly 3.14, 1579. If I went to the aerospace engine, the aerospace guy, he might need pi over to 7 decibels. I hand it to the pharmacist. I hope the pharmacist is a little bit more concerned than being pretty close. Because a pharmacist is off by 100 thousandths of an inch, then I die. He can't just put, that's about right. Well, the carpenter can do that. Because if it's not lined up perfectly, he'll just maybe do some more on the flat tire. Because if you do your hand on this wood, completely mix it up. So we've got a little tool right here. Those aren't exactly 100% perfect, but that was a little higher. That brings a little higher up. But it's okay. He pulls one line right here, and close enough is okay with this. Close enough is not okay with the engineer of the car. He doesn't need square root of 21 pretty close. He needs exact answers. So as a mathematician, we give them square root of 21. If they want to simplify that down further, that's up to them on where they are in their, what their job description is or whatever. So now I got the square root of 208, and I say 2 goes into there 104 times, 2 goes into there 52 times, 2 goes in there 26 times, 2 goes in there 13. All right, now, again, we circle 1. What's next? Cross 1 out. Circle 1, cross 1 out. Can I circle the 13? No. So I don't cross anything out. Remember, again, guys, this isn't, oh man, I just got it backwards. It isn't that kind of mistake. When you circle the things, they go out front. 2 times 2 is 4. When you don't circle the thing, it goes underneath. So my final answer to this one is 4 on the square root of 13. Notice the difference as to when x squared is out front and when it's the hypotenuse. When x squared is a leg, you go 64 plus x squared equals 144. Now this 64 needs to be moved to the other side. So when I subtract, that's not right. 144 is not, 14 squared is 196. So x squared equals, move that 64 to the other side. So that gives me 132. Again, take the square root of both sides. X equals square root of 132. I don't know whether or not square root of 132 simplifies. And guys, there's nothing you can do but see if you can find the prime factorization of 132. 2 goes in there 66 times. 2 goes in there 33 times. 3 goes in there 11 times. Circle 1 factor, cross 1 out. Can I circle the 3? Because there's nothing to cross out. Can I circle the 11? There's nothing to cross out. If you can't circle 1, you can't cross 1 out. So everything that ends up being circled, everything that ends up being not circled. 2 on the square root of 33, which is what it said right here. 2 on the square root of 33.
Why did you keep simplifying number 21?
Number 21,
Yeah.
square root of 218. I thought I did.
You continue on some of them, but then on some of them.
It should continue on the ones that it does. Where is that? What number is it?
Number 21.
It should say 4 on the square root of 13. It just, in the answer key, it didn't simplify it, but it should.
No.
This, 21, 218. Well, I didn't do that one, did I?
No, you did, but like Some of them
I didn't do 49 plus 169 equals x squared. So when you add those together, 218 equals x squared. So x equals square root of 218. So I come over here, I do the prime factorization of 218, and 2 goes in there 109 times, and that's it. I did simplify it. It doesn't simplify. That's the only two factors that'll go into that. There's no number that'll go into 218. 218 is a composite number, but 109 is prime, and 2 is prime. So that's my prime factorization. There aren't more factors down through here.
So that's why you didn't do it for number 19 too.
Yeah, because it's 3 and 7. There's nothing to cancel out. You see your question? It's spot on. It's exactly what you need to be realizing. I can't cancel out the 3. I can't cancel out the 7.